The pulse component retriggers selected steps in your sequence. To add a pulse component, hold Shift and press the step. Then press the pulse component followed by a value key. In this example, the hi-hat on the 4th beat now triggers twice. To change the number of retriggers, hold Shift and select the step again. Long press the pulse component key and then select a new value. The hi-hat on the 4th beat now retriggers 4 times instead of 2. Value keys 1 to 9 work in the same way, however value 0 randomizes the amount of triggers with each cycle. In this next example, 2 synths play the same melody, one pan left and the other pan right. Let's apply a pulse component of value 2 to the left-hand synth. With each cycle, the pattern shifts further out of phase due to the extra step added by the pulse component. The pulse hold component sustains a note for a selected number of steps. This is very similar to the pulse component. To add a pulse hold component, hold Shift and select a step, then press the pulse hold key followed by a value key. In this example, the 4th note now sustains for 3 steps. Values 1 to 9 work in the same way, however value 0 randomizes the hold length with each cycle. In this next example, 2 synths play the same melody, one pan left and the other pan right. Let's add a pulse hold component to the left-hand synth of value 2. With each cycle, the pattern shifts further out of phase due to the length of the held note. The multiply component retriggers a single step. To add a multiply component, hold Shift and select the step, then press the multiply component key followed by a value. The hi-hat now triggers twice in the space of 1 step. You can apply the same component to multiple steps by holding Shift and selecting them. We've applied the multiply component of value 4 to these 2 steps. Values 1 to 8 multiply the amount of retriggers, however value 9 creates a broken chord effect. For this example, we're going to select the chord track and apply a broken chord effect to the last step of the sequence, using the multiply component. Now let's add the rest of the pattern, which makes frequent use of the multiply component. Nice. The velocity component allows you to manually set the velocity of a step. For this example, we're going to add a shaker to this sequence. Select the shaker, then add it to each of the 16 steps. Each note has the same velocity, so it sounds pretty artificial. To fix this, hold Shift and select the offbeat steps. Then select the velocity component and set value to 4. Much better. Values 1 to 4 reduce velocity, 5 sets to default, 6 to 8 increases velocity, 9 mutes, and 0 randomizes. For added swing, let's reverse every 4th step. The ramp-up component increases the pitch of a step over a set range with every cycle. To add this component, hold Shift and select steps, then select the ramp-up component. The value keys determine the range of the pitch increase before it returns to the starting note. Let's change the value of these from 4 to 8. Now the notes increase over a 3-octave range instead of 1. Ramp-up also works on pitch samples. Let's add a ramp-up component to each of these steps. The samples now increase in pitch consecutively. Let's add the rest of the track in. The ramp down component works the opposite way to the ramp up component. Add this component to steps and you'll notice the pitch starts high and gradually decreases with every cycle. Value keys still determine the pitch range. Let's change the value of these steps from 4 to 8. Now the notes decrease over a 3-octave range instead of 1. Ramp down also works on pitch samples. Let's add a ramp down component to each of these steps. The samples now decrease in pitch consecutively. Let's add the rest of the track. The random component randomizes the pitch value of a step. Here's a 16-step sequence of the same note to demonstrate. To add a random component, hold Shift and select Steps, then select the random component. Random notes are selected every cycle from a fixed range, determined by the scale and a value key. Adding the random component to steps 9 to 16 with a value of 8 increases the random note range for those steps. Random notes can be set to ignore the chord progression using the master track. The Portamento component adds glide time between consecutive notes. To add the Portamento component, hold Shift, select Notes, and then select the Portamento component. You'll notice the selected notes slide into pitch from the previous step. Portamento can also be added in the track parameters, however step components allow you to add Portamento to individual steps much quicker. Values 1 to 8 affect glide time, with 1 being the quickest and 8 being the slowest. Let's demonstrate this here starting with value 4. It's worth mentioning that value 9 removes Portamento and value 10 randomizes glide time with each cycle. The sweep component modulates track parameters, filter and pan. In this example, we're going to add different sweep components to each track. To add a component, hold Shift, select the step, then select the sweep component. Value 1 sweeps the filter up, then down over one cycle. Now we're going to add a sweep component to the bass track, repeating the same process but selecting value 4. This sweeps synth parameter 1 down, then up over one cycle. Let's use the sweep component to give these hi-hats some movement. You'll need headphones or speakers to hear this effect. Selecting value 5 modulates the panning of the hi-hat left and right. For each of these examples, you only need to add one sweep component to affect the rest of the steps in your track. If you need a more gradual sweep, value keys 6 to 0 double the length of the modulation. The tonality component transposes the pitch of selected steps. To add the tonality component, hold Shift and select Steps, then select the tonality component. Each value key represents a different transposition type as shown. We're going to select value key 1 for this next example. This locks down the notes of the lead line, ignoring changes made to the chord progression. To demonstrate this, let's select the master track and record changes to the chord progression. As you can see, the bass line follows the progression but the lead line does not. We can quickly remove all step components from a track by holding Shift and Stop. Now you'll notice the lead line is following the chord progression of the master track. Adding the tonality component with value 8 to 0 locks notes to set intervals, which shift with the chord progression. The jump component relocates the active step to a predetermined position in the sequence. To add the jump component, hold Shift and select a step, then select the jump component. Once the selected step is triggered, it then jumps to the second beat of the bar determined by value key 2. If we change this value to 3, the active step will jump to the third beat of the bar. The same logic applies for value 1 jumping to the first beat and value 4 jumping to the fourth. Let's add in the rest of the track. Now we're going to change the value of the jump component again. This time we'll select value 5. This value skips over the next step in the sequence, causing the pattern to phase. Let's try value 7. This value randomizes where the active step will land each time it's triggered, creating some unexpected results. Now let's try a new jump component with value 8. This value freezes the sequence on the selected step. It's worth mentioning that if you want to realign a track with the rest of the pattern, you can always use a jump component with value 9 on any step. Spark components determine whether a parameter, component, or trigger is activated per cycle. We're going to use each type to add variations to this 16-step pattern. First, we'll add the trigger spark to the 12th and 13th step of the kick track. The flashing value key indicates which cycle will activate the trigger. In this case, step 12 is triggered exclusively in bar 1 and step 13 in bar 2. Next, we'll add the parameter spark to the chord track. The same principles apply, but instead they activate step-locked parameter changes. In this instance, we're going to increase the release time on step 4 of the chord track by holding the step and adjusting the release. Then adding a parameter spark with flashing value 3 will activate this parameter change every third bar. Next, we'll add the component spark to the percussion track. This is used to activate other step components. Let's add the ramp up component to the first 4 steps. We can add the component spark in combination with ramp up to activate it every other bar. Now let's add the multiply component to steps 4 and 13. Continuing to hold shift, we can then add a component spark of value 4 without having to reselect steps. You can use this method to add any combination of components to a single step in one go. Finally, we're going to use the trigger spark and component spark to make this bass line less repetitive. We'll use the trigger spark to activate the second half of the bass line every third bar. Then we're going to use a combination of the component spark and transpose component to shift step 4 up an octave every third bar. You'll notice this aligns with the parameter spark in the chord track. Spark components are ideal for adding variation and fills without having to extend your step count with alternating patterns or track multipliers. If you want to revert to your original pattern, all you have to do is remove the spark components.